Chapter 10b, Section 10.6, Parametric Equations. So up until now, mostly we've been looking at equations in terms of x and y combined together. So horizontal and vertical position put together, giving us a single graph. In this section, we're going to look at times it can be helpful to have a third variable, that both x and y are defined or in terms of. That variable t usually denotes time. So as a universal measure, what is our horizontal and our vertical position separately of each other? Okay? So velocity of an object, we've seen this before. Y equals x squared negative x squared over 72 plus x. So x and y in an equation. If you have a horizontal position, can you find also a vertical to go with it, or vice versa? That is the rectangular equation. The parametric equations, so plural, there's one for x in terms of t, so at this specific time, horizontally, this is our position. At this specific time, vertically, this is our position. And these two x and y equations can combine together to give us a parabola that we know and love, like we would have had in rectangular form. But in this one, we have at time t, we're at the origin. At time t, we're at a maximum. At time t, we're back at the x-axis. Okay, so everything now turns to t, what's our horizontal and vertical, and then kind of compile those two together. So, kind of how we look at this, okay, how we initially graph these. Gonna kind of go back to the beginning. So when you first learned about equations in rectangular form, you would make t-tables and graph them. X and y columns, choose x values, get y values, then plot them. Now we have t as the universal measure. Okay, so x is t squared minus 4, y is t over 2. So whatever the time is, we'll find the horizontal and the vertical positions separately, then put them together in a graph. So choose some t values and get your x and y values. So x is t squared minus 4, so 4 squared minus 4, that will be 0. Sorry, negative 2 squared will be 4 minus 4, that's 0. Okay. For y, t over 2, that will be negative 1. For negative 1, 1 squared minus 4, negative 3, negative 1 over 2, negative 1 half. At 0, we have negative 4 and 0. At 1, we have again negative 3. At y equals 1, we have 1 half. And we just keep filling in this table. And 5 and 3 halves. Okay. And then plot the points. So 0, negative 1, right there. Negative 3, negative 1 half. Negative 4 is 0. Negative 3, positive 1 half. 0, 1. And 5, 3 halves. So we see this object, then these points form a parabola. So, pretty good. Then if you want to, why not put an arrow in the end, because this object will keep going. So You can see as time goes on, this object moves to the left, then it goes back to the right. Horizontally, vertically, we're going up pretty consistently. Of course, this makes sense if we look at the x and y equations. X is a quadratic, so we'll see quadratic motion on the horizontal. Y is linear, so the linear increases on the vertical axis. Eliminating the parameter. Let's say we have parametric equations and we're like, well, we don't want those anymore. We kind of fancy rectangular equations today. So this is pretty similar to solving systems using substitution. Solve for t in one equation. So in this y equation, multiply both sides by 2, 2y equals t. Substitute to that into the other equation for t. So x equals 2y squared minus 4. And then solve. Well, x equals 4y squared, getting a little sloppy, minus 4. And it's an equation, so not necessary to solve for y. If you want to, if that floats your boat, find your lost TV remote, go ahead. But it's an equation, you can leave it as such. So in these 3 examples, put them into rectangular form, then check your answers with my completed notes online. Finding parametric equations, okay? So if you want to go from rectangular to parametric, first you need a parameter. You need to introduce t. How is t going to affect your x's and or your y's? So we know y is 1 minus x squared. X equals t. So we're going to use x equals t as our parameter. So then plug t in for x in your y equation. So y equals 1 minus t squared. And when you're finding parametric equations, you want 1 x with that 1. Oh boy, that's better. 1 x equation. And you want 1 y equation. And if we look, we have both those here. We have an x and we have a y. So we have found parametric equations for the x equals t parameter. Example B, check your work with my completed notes online.